Assalamualaikum. Today I have come with some problems from the sequence. Here, first I try to show you some formula from this chapter. If A denotes the first term and R denotes the common ratio of its general standard form of a sequence, common ratio of a sequence, then the general or standard form of a geometric progression is A R square and A R cube. That is, if A is first term and R is common ratio, then the sequence will be like this, and the n term will be AR to the power n minus 1, and sum of first n terms will be Sn is equal to A into A times 1 minus R to the power n divided by 1 minus R, where R not equal to 1. And if for if R not equal to 1 and also 1 greater than R, and if R greater than 1, then the formula will be A times R to the power n minus 1 R minus 1. And how we can understand our given sequence is arithmetic progression or geometric progression. If the difference between second term and first term and also third term and second term equal, then that progress sequence will be arithmetic progression. And ratio of two consecutive terms will be equal. If the ratio of two consecutive terms is equal, then the progression then sequence will be geometric progression. Now this is a problem. If the sequence is like this: log 3, log 9, log 27, log 81, we have to set that is this a arithmetic progression or geometric progression. First we have to see the ratio of two terms. Here we can see that if we divide log 9 by log 3, that will be log 9, we can write this log 3 square, and our result will be 2. The ratio of these two terms will be 2, and similarly the ratio of second and third terms will be 3 by 2. That is, these ratios are not equal, but the difference, if we take the difference log 9 and log 3, and this will be log 3, and also log 9 and difference of log 9 and log 27 are also log 3. So that's why this given sequence is an arithmetic progression. Now if we see the another problems, here we can see that we have given this sequence. Now we have to show, first we have to see the ratio between two terms. If we see the ratio between second and first term, this is 3 to the power x, and third and fourth term, ratio of third and fourth term will be also be 3 to the power x. So these two ratios are equal. Since these two ratios are equal, this sequence is a geometric progression. Now this is another sequence: minus 5, 25, minus 1, 25, 625. Here first term is minus 7, and the ratio 25 divided by minus 5 is minus 5. We know the formula of n term, AR to the power n minus 1. So the value of n will be 10 here. So AR to the power 10 minus 1, and our 10 term is minus 5 to the power 10, because here my power of minus 5 here 1, and minus power of minus 5 again here 10 minus 1. So when we take when the base will, and the base is same, so power we can add the power here, right? 1 plus 10 minus 1. Similarly, n term of that sequence will be AR to the power n minus 1, and after calculating minus 5 to the power n. Now another sequence: 4, 2, 1 and half. Here first term is 4, and ratio is 1 by 2, and n term will be AR to the power n minus 1. That is, if we put the value of R here, we get 4 divided by 2 to the power n minus 1. We can write 4 by 2 square, and base is same, and since it is in division form, we have to subtract the power to 2 minus n plus 1. So our n term will be 2 to the power 3 minus 1, and 10th term will be 2, 2 to the power 3 minus 7, that is 2 to the power minus 7. Now we have another problem here. This is a word problem. The problem is the length of the sides of a triangle form a geometric progression. If the shortest side is 9 cm and the perimeter is 37 cm, you have to find the length of other two sides. We know if three sides of the triangle are ABC and A is the shortest side, then A, according to question, A will be 9 cm and perimeter, that is A plus B plus C, will be 37 cm. And this is equation 1. And if common ratio of the length of sides is R, then B by A, C by B is equal to R, according to ratio, definition of common ratio. Then B, which implies B is equal to AR, and then we get C is equal to BR, that is C is equal to AR square. So from equation 1 now we get A, and for B we get AR, and for C we get AR square. And now we put the value of A, 9 plus 9R plus 9R square is equal to 37, and by changing side we get 9R square plus 9R minus 27. And now we have to factorize this expression from left hand side. After factorizing it, we get the value of R is minus 7 by 3 and 4 by 3. Minus 7 by 3 is not applicable, so by taking 4 is 4 by 3, length of 3 sides will be 9 times 4 by 3 and 9 times 4 by 3 whole square, and 3 sides of this triangle are 9, 12 and 16. We have another problem of similar kind. Length of 3 sides of a triangle form a geometric progression, and we are given that shortest side of the triangle is 10 cm and the common ratio is R. We have to explain that is it possible for R to be 1 by 5 but not possible for R to be 2. So a similar way we start like previous one. A is the first term and R is common ratio. The standard form geometric progression, we know that A AR square AR cube, A AR AR square AR cube, and here A is 10 and R is 1 by 5. Then we get AR, value of AR will be 15 and AR square will be 22.5. So the three sides of the triangle will then 10, 15 and 22.5. If we see that 10 plus 15 greater than 22.5, because 10 plus 15 is 25, which is greater than 22.5. So this satisfies the characteristics of triangle, which is sum of length of two sides will be greater than other sides. But if we take A is 10 and R is 2, then we get the three sides of triangle will be 10, 20 and 40, which does not satisfy the characteristics of properties of triangle, which is 10 plus 20, 10 plus 20 is 30, which is greater than 40, which, that is not possible for the triangle, because we know that sum of two sides always, sum of length of two sides of a triangle always be greater than the other sides. So that's why R cannot be 2 but R can be 1.5. Another problem from the same topics. Find x if the numbers x plus 3, 5x minus 3 and 7x plus 3 are three consecutive terms of a geometric progression of positive terms. With this value of x, and given that x plus 3, 5x minus 3 and 7x plus 3 are third, fourth and fifth terms of the geometric progression, we have to find the sum of the first 8 terms of the progression. We know that R is equal to 5x minus 3 divided by x plus 3, and ratio of second terms and first terms, and ratio of third terms and second terms. These are common definition of common ratio. and from this we get 5x minus 3 whole square is equal to 7x plus 3 into 7 times 7x plus 3. From this we get if applying the whole square of a minus b whole square formula, we get 25x square minus 30x plus 9, and in the right hand side if we multiply these two expression we get 7x square plus 3x plus 21x plus 9. And if we change the side of this expression, we bring this to the left hand side, and we get 18x square minus 54x. If we take common 18x, then we get x minus 3, and which implies the value of x will be 0 or 3, but x is equal to 0 is not applicable, acceptable here. So if x is equal to 3, then our third and fourth fifth terms will be 6, 12 and 24, and we know third term is from the formula of the n term. We know that our third term is ar to the power 3 minus 1, which is ar square, but our r we is because our sequence we get here is 6, 12 and 24, right? We get our sequence is 6, 12 and 24, so ratio will be 12 divided by 6, which is 2, and it is greater than 1. But we our third term is ar square, so ar square will be 6, right? Because 6 is third term, we have given in our question. So value of a will be 6 by r square, that is 3 by 2, right? So our first term is 3 by 2. Okay, so now sum of 8 terms will be a times r to the power n minus 1 divided by r minus 1, and this is our sum of 8 terms. So that's it. This is the solution of the problem from sequence. I have tried to give you some explanation from the sequence chapter, and these are some critical problems. Hope this will benefit you, and please support me and subscribe my channel. And if you have any problems, drop in the comment box. I will try to solve your problems. Thank you everyone.